Hi, Pragnesh. Hello, I think you're a new user. Good morning, good evening, good afternoon, good any time of day it is on your side of the world. What's up? Let me know if the internet, if my streaming quality is bad, because I think I might have issues, and if I don't, then great. So please do let me know about that. There is a tiny thing. Today I will probably be able to stream only for half an hour. Like, half an hour sounds like a lot when you have to wait for something, but when you do something you like and you have to do it only for half an hour, then thanks for the emojis. Then you're sad, because like, why only wait half an hour? Why only be here for half an hour? So yeah, sorry about that. And let me know if you need anything, if you have any questions, any points, anything. Otherwise, I will be doing a recap, and then 1 second. And then share my screen. There, okay. So what we're doing right now, this stream, is we are studying Kaggle's Introduction for Coders. This is stream number 11. Yes. We have been studying lesson 1, 2, 3. We're currently in lesson 4 according to this link over here. Yes, we've done a lot of random forest related things, and yeah, I will continue doing that. If you happen to have any questions or anything you'd like to say to me, please do. I don't mind chatting with you guys. I'm gonna start the lesson from Jeremy Howard. I think the internet is good. The internet on my side. Okay.
Didn't get worse significantly when I removed them. So now I'm at the point where I want to try and really understand my data better by taking advantage of the model. And we're going to use something called partial dependence. And again, this is something that you could use in the Kaggle kernel, and lots of people are going to appreciate this because almost nobody knows about partial dependence. And it's a very, very powerful technique. What we're going to do is we're going to find out, for the features that are important, how do they relate to the dependent variable, right? So Let's have a look, right? So let's, again, since we're doing interpretation, we'll set RF samples to 50,000 to run things quickly. We'll take our data frame, we'll get our feature importance, and notice that we're using max and cat, because I'm actually pretty interested in terms of for interpretation and seeing the individual levels.
What max and cat? I didn't see any cats. Oh, normal. Normal. I
Notice that we're using
max features min. What cat? Here. Max and cat? Do I know what that stands for? Categories. Max number of categories. This means something. How many number of categories within a feature for you to turn it into it's not one hot encoding, is it? It's just numbers, I think.
Max and cat, because I'm actually pretty interested in terms of for interpretation and seeing the individual levels. And so here's the top 10. And so let's try and learn more about those top 10.
Mm-hmm.
So year made is the second most important. So one obvious thing we could do would be to plot year made against sale elapsed, because as we've talked about already, like, it just seems to make sense. They're both important, but it seems very likely that they kind of combine together to find like how old was the product when it was sold. So we could try plotting year made against sale elapsed to see how they relate to each other. And when we do, we get this very ugly graph. And it shows us that year made actually has a whole bunch that are 1,000.
Yes! Oh my god, we noticed this last time when we did the pandas profiling. We noticed that there is like 9% of the data, it's just the number 1,000. And now he's noticing that now. We're cool.
Right, so clearly, this is where I would tend to go back to the client or whatever and say, okay, I'm guessing that these bulldozers weren't actually made in the year 1000. And they would presumably say to me, oh yes, they're ones where we don't know when it was made.
Yes, so their null value is 1,000 for a year, which is not right.
Maybe before 1986 we didn't track that, or maybe the things that are sold in Illinois don't have that data provided, or whatever. They'll tell us some reason. So in order to understand this plot better, I'm just going to remove them from this interpretation section of the analysis. So I'm just going to say, okay, let's just grab things where year made is greater than 1930. Okay. So let's now look at the relationship between year made and sale price. And there's a really
people like products from the 90s.
really great package called ggplot. ggplot.
Good game plot? What? This is cool. What does AES stand for?
Originally was an R package. GG stands for the grammar of graphics. And the grammar of graphics is like this very powerful way of thinking about how to produce charts in a very flexible way. I'm not going to be talking about it much in this class. There's lots of information available online, but I definitely recommend it as a great package to use. ggplot, which you can pip install, it's part of the fast.ai environment already. ggplot in Python has basically the same parameters and API as the R version. The R version is much better documented, so you should read its documentation to learn how to use it. But basically you say, okay, I want to create a...
Hello, good morning, welcome. What's up? I started the stream a tiny bit earlier than normal because I will be leaving in less than half an hour. So I wanted to do something at least today because I want to keep the consistency no matter how small. A person is a person no matter how small. Oh. Good morning, good morning. I don't know if you saw, but I'll go back a bit and then come back to where we are. Jeremy Howard just noticed that the data has a lot of thousands and then normal years, and he was like, no worries. So yeah, he noticed that there's a lot of thousands in the data where it's year. So he was like, we noticed it way earlier because we were doing the profiling on pandas. So I felt cool that I noticed before him. And now we're looking at just the relationship between year made and sales price.
This very powerful way of thinking about how to produce charts in a very flexible way. I'm not going to be talking about it much in this class. There's lots of information available online, but I definitely...
100%, yeah, it did help.
definitely recommend it as a great package to use. ggplot, which you can pip install, it's part of the fast.ai environment already. ggplot in Python has basically the same parameters and API as the R version. The R version is much better documented, so you should read its documentation to learn how to use it.
Will do.
But basically you say, okay, I want to create a plot of this data frame. Now, when you create plots, most of the data sets you're using are going to be too big to plot. As in, like, if you do a scatter plot, it'll create so many dots that it's just a big mess. It'll take forever. And remember, when you're plotting things, you're looking at it, right? So there's no point plotting something with 100 million samples when if you only used 100,000 samples, it's going to be pixel identical, right? So that's why I call get sample first. So get sample just grabs a random sample. Okay, so I'm just going to grab...
To build something fast from a smaller sample? I mean, that's useful to just look at the data, but how can you know how representative this sample is?
500 points for now. Okay, so I've got to grab 500 points from my data frame. I've got to plot year made against sale price. AES stands for aesthetic. This is the basic way that you set up your columns in ggplot. Okay, so this says to plot these columns from this data frame, and then there's this weird thing in ggplot where plus means basically add chart elements. Okay, so I'm going to add a smoother. So most of very, very often you'll find that a scatter plot is very hard to see what's going on because there's too much randomness, whereas a smoother basically creates a little linear regression for every little subset of the graph. And so it kind of joins it up and allows you to see a nice smooth curve. Okay, so this is like the main way that I tend to look at univariate relationships.
And does the gray mean other points of data that weren't smoothed out very well? What does the gray stand for?
And by adding standard error equals true, it also shows me the confidence interval of this smoother, right? So low S stands for locally weighted regression, which is this idea of doing lots of little linear regressions. So we can see here the relationship between year made and sale price is kind of all over the place, right? Which is like not really what I would expect. I would have expected that
just to continue go up by the newer that the trucks got, but like there's this love of old things that were sturdier, so I don't blame them. And then people like the new stuff, but 2000s not so much.
More recent stuff that sold more recently would probably be like more expensive because of inflation and because they're like more current models.
Expensive. I guess this is price, not units sold. In my brain it was units sold. Do we have that information?
So forth. And the problem is that when you look at a univariate relationship like this, there's a whole lot of collinearity going on, a whole lot of interactions that are being lost. So for example, why did the price drop here? Is it actually because like things made between 1991 and 1997 are less valuable? Or is it actually because most of them were also sold during that time and actually there was like maybe a recession then?
Yeah, definitely recession related.
Or maybe it was like the product sold during that time, a lot more people were buying types of vehicle that were less expensive. Like, there's all kinds of reasons for that. And so again, as data scientists, one of the things you're going to keep seeing is that at the companies that you join, people will come to you with these kind of univariate charts where they'll say like, oh my God, our sales in Chicago have disappeared, they've got really bad. Or people aren't clicking on this ad anymore, and they'll show you a chart that looks like this. And they'll be like, what happened? And most of the time, you'll find the answer to the question, what happened, is that there's something else going on, right? So actually,
the third reason. Because like he pointed out as well as I did, this is sale price, not units sold. So maybe things just got cheaper for some reason.
in Chicago last week, actually, we were doing a new promotion, and that's why our revenue went down. It's not because people aren't buying stuff in Chicago anymore. It's because the prices were lower, for instance. So what we really want to be able to do is say, well, what's the relationship between sale price and year made, all other things being equal? So all other things being equal basically means if we sold something in 1990 versus 1980 and it was exactly the same thing to exactly the same person in exactly the same auction, so on and so forth, what would have been the difference in price? And so to do that, we do something called a partial dependence plot.
Whoa. This at the same time reminds me of just hair, human hair, and cotton candy.
And this is a partial dependence plot. There's a really nice library which nobody's heard of called PDP, which does these partial dependence plots. And what happens is this. We've got our sample of 500 data points, right? And we're going to do something really interesting. We're going to take each one of those 100 randomly chosen.
Is there a cotton candy emoji? I know there is candy, but is there a cotton candy? No. No worries.
And we're going to do something really interesting. We're going to take each one of those 100 randomly chosen auctions, and we're going to make a little data set out of it, right? So like here's our come on, one more. Here's our data set of like.
Okay, so he's not used to the OneNote issue where things get hidden if you don't use the tab for a while and then go back to it.
500 auctions. And here's our columns, one of which is the thing that we're interested in, which is year made.
Mm-hmm.
So here's year made.
Mm.
Okay. And what we're going to do is we're now going to try and create a chart where we're going to try and say, all other things being equal, in 1960, how much did bulldozers cost? How much did things cost in auctions? And so the way we're going to do that is we're going to replace the year made column with 1960. We're going to copy in the value 1960 again and again and again all the way down.
Wow. So we're just duplicating the data for every year point we have and plotting everything?
Right? So now every row, the year made is 1960. And all of the other data is going to be exactly the same. And we're going to take our random forest, and we're going to pass all this through our random forest to predict the sale price. So that will tell us, for everything that was auctioned, how much do we think it would have been sold for if that thing was made in 1960. And that's what we're going to plot.
How does that make sense? Like, it's cool. It helps you look at the data, but how does that make sense?
Here. All right, that's the price we're going to plot here. And then we're going to do the same thing for 1961. All right, we're going to replace all these and do 1961. Yeah.
So, well, to be clear, we've already fit the random forest.
Yes.
And then we're just passing a new year and seeing what it determines the price should be?
Yeah, so this is a lot like the way we did feature importance. But rather than randomly shuffling the column, we're going to replace the column with a constant value. Right? So randomly shuffling the column tells us how accurate it is when you don't use that column anymore. Replacing the whole column with a constant tells us, or estimates for us, how much we would have sold that product for in that auction, on that day, in that place, if that product had been made in 1961. Right? So we basically then take the average of all of the sale prices that we calculate from that random forest. And so we do it in 1961, and we get this value, right? So what the partial dependence plot here shows us is...
So we're passing it to our trained model. Anyway, he used the word fit, but it's almost like telling it to predict if it was in the year that we decided. But like, how can we, what do we do about this graph? How do we interpret it then?
Because each of these light blue lines actually is showing us all 500 lines. So it says for row number 1 in our data set, if we sold it in 1960, we're going to index that to 0, right? So we'll call that 0, right? If we sold it in 1970, that particular auction would have been here. If we sold it in 1980, it would have been here. If we sold it in 1990, it would have been here. So we actually plot all 500 predictions of how much every one of those 500 auctions would have gone for if we replace its year made with each of these different values. And then this dark line here is the average, right? So this tells us how much would we have sold.
Cost continuously goes up. This is what it tells us.
On average, all of those auctions for, if all of those products were actually made in 1985, 1990, 1993, 1994, and so forth. And so you can see what's happened here is, at least in the period where we have a reasonable amount of data, which is since 1990, this is basically a totally straight line. Which is what you would expect, right? Because if it was sold on the same date, and it was the same kind of tractor, and it was sold to the same person in the same auction house, then you would expect more recent vehicles to be more expensive,
pricey,
because of inflation and because they're newer. Right? They're not as secondhand. And you would expect that relationship to be roughly linear. And that's exactly what we're finding. Okay? So by removing all of these externalities, it often allows us to see the truth much more clearly. There's a question at the back. Can you pass that back there? You're done. Okay. So this partial dependence plot concept is something which is using a random forest to get us a more clear interpretation of what's going on in our data. And so the steps were to, first of all, look at the feature importance to tell us, like, which things do we think we care about, and then to use the partial dependence plot to tell us what's going on average, right? There's another cool thing we can do with PDP is we can use clusters. And what clusters does is it uses cluster analysis to look at all of these, each one of the 500 rows, and say, do some of those 500 rows kind of move in the same way? And like we can kind of see, it seems like there's a whole lot of rows that kind of go down and then up.
This is like time series. Would the cluster analysis not be a time series?
And there seems to be a bunch of rows that kind of go up and then go flat. Like, it does seem like there are some kind of different types of behaviors being hidden. And so here is the
it is still a time series, but clearer.
Result of doing that cluster analysis, right, is we still get the same average, but it says here are kind of the 5 most common shapes that we see. And this is where you could then go in and say, all right, it looks like some kinds of vehicle, actually after 1990, their prices are pretty flat.
But what is this? You know, like, the only information we're getting, year made. What is that? Price, right?
And before that, they were pretty linear. Some kinds of vehicle are kind of exactly the opposite.
What is the kind?
And so, like, different kinds of vehicle have these different shapes, right? And so this is something you could dig into. I think there was one at the back. Oh, you could. Okay.
So what are we going to do with this information?
Well, the purpose of interpretation is to learn about a data set. And so why do you want to learn about a data set? It's because you want to do something with it, right? So in this case, It's not so much something if you're trying to win a Kaggle competition. I mean, it can be a little bit. Like some of these insights might make you realize, oh, I could transform this variable or create this interaction or whatever. Obviously, feature importance is super important for Kaggle competitions. But this one's much more for like real life, you know? So this is when you're talking to somebody and you say to them like, okay, those plots you've been showing me, which actually say that like there was this kind of dip in prices, you know, based on like things made between 1990 and 1997. There wasn't really, you know, actually they were increasing. There was actually something else going on at that time. You know, it's basically the thing that allows you to say like, for whatever this outcome I'm trying to drive in my business is, this is how something's driving it, right? So
How sure can you be when you use these things? Like, I know it makes sense, but like, try to explain it to a robot. Maybe a robot would understand it better. Honestly, I don't know. There's also the thing, explain it to me like I'm 5, or explain it to your grandma. Why are we this type of this? You know, like making all the data that year and then predicting it. Why?
If it's like I'm looking at, you know, kind of advertising technology, what's driving clicks, then I'm actually digging in to say, okay, this is actually how clicks are being driven. This is actually the variable that's driving it. This is how it's related. So therefore, we should change our behavior in this way. That's really the goal of any model. I guess there's 2 possible goals. One goal of a model is just to get the predictions. Like if you're doing hedge fund trading, you probably just want to know what the price of that equity is going to be. If you're doing insurance, you probably just want to know how much claims that guy's going to have. But probably most of the time, you're actually trying to change something about how you do business, how you do marketing, how you do logistics. So the thing you actually care about is how the things are related to each other.
All right, I'm sorry, can you explain again, when you scroll up and you were looking at the sale price year May, looking at the entire model, and you saw that dip, and you said something about that dip didn't signify what we thought it did. Can you explain why about that?
So this is like a classic, boring univariate plot, right? So this is basically just taking all of the dots, all of the options, plotting year made against sale price, and we're going to just fitting a rough average through them. And so it's true that products made between 1992 and 1997, on average in our data set, are being sold for less. So like very often in business, you'll hear somebody look at something like this and they'll be like, oh, we should stop auctioning equipment that is made in that year, in those years, because like we're getting less money for example. But if the truth actually is that during those years, it's just that people were making more small industrial equipment, where you would expect it to be sold for less, and actually our profit on it is just as high, for instance. Or during those years, it's not things made during those years now would be cheaper. It's that during those years, when we were selling things in those years, they were cheaper because like there was a recession going on. So if you're trying to like actually take some action based on this, you probably don't just care about the fact that things made in those years are cheaper on average, but how does that impact today?
Okay. I mean, it's a really fair point, especially you shouldn't trust one graph and make it like this is the only truth out there in the world. So having different types of graph, looking at the data in a different way, does help you understand it better and not having one understanding. Fair point.
You know, so this approach where we actually say, let's try and remove all of these externalities. So if something is sold on the same day to the same person of the same kind of vehicle, then actually how does year made impact price? And so this basically says, for example, if I am deciding what to buy at an auction, then this is kind of saying to me, okay, like getting a recent vehicle on average really does, on average, give you more money, which is not what the kind of the naive univariate plot said. I can pass it to Tyler.
For like this bulldozer, bulldozers made in 2010 probably are not close to the type of bulldozers that were made in 1960.
Right.
And if you're taking something that would be so very different, like a 2010 bulldozer, and then trying to just drop it to say, oh, if it was made in 1960, that may cause poor prediction at the point because it's so far outside of any training set.
Absolutely. So, I think that's a good point. It's, it's a limitation of a random forest is if you've got a kind of data point that's like of a kind, which is kind of like in a part of the space that it's not seen before. Like maybe people didn't put air conditioning really in bulldozers in 1960, and you're saying how much.
Hello? Am I still streaming? Because... Okay, maybe. Because I'm monitoring the stream on my phone and it just dropped there. And then I'm opening it again and I think it's still running, but I thought it stopped. I mean, I really want to continue watching this, and when I start again tomorrow, I will have to go back to get that student's question, which I did. It's the same question that I have, but I really have to go. Okay, I thought it dropped. For some reason, YouTube just, I don't know, on my phone it dropped it. Okay, I have to go. Today and yesterday I have some external responsibilities. So yeah, I will do my best to make it up on the weekend. I can't promise. I actually can make a promise. I don't know if I should. Wednesday is a holiday. I hope it's a holiday for all the Muslim countries. It's Maulid Nabawi. So thank you. I'll do my best. So I can stream longer on that day. Wednesday and weekends. Those are the days that I can stream for longer. Otherwise, an hour and a half is the usual. And then we have different, yes. It will be a lovely day. So yeah. I will do my best. Some hearts for, someone else gave hearts, or was it just me? I'm trying to give hearts. Okay. For Maulud Nabi. See, YouTube is dropping me on my phone again and saying live ended. Not true. I'm gonna end it now, just to make you mad. Not you, YouTube. Okay. So yeah. The possibility of us finishing lesson 4 tomorrow is pretty high, so inshallah we'll do that. Tomorrow is... it's Wednesday! So yes, tomorrow is the day where we can study better. And I know I am not following him with the lesson 2 thing, so I'm gonna do that. But here's the thing. I really, really wanna do Kaggle test, even if I'm just looking at what people did to solve it, even if I'm not writing the code myself. The one that's contradictory, my dear Watson, I think after I finish lesson 4 I might go for that instead of starting lesson 5. I'm not sure. I will need your support. So yes, internet not good, I think. Sorry about that. See you tomorrow, hopefully, if you feel like coming back. If not, no worries. Everybody is a person, I think, and we have responsibilities that we don't always, it doesn't always mean we can control our time. Being adult is fun. Okay, thank you for your time and energy, and Yep. Let me know if there's anything I needed on my side. If not, see you tomorrow. And yeah, that's it. Thank you. I'm gonna end the stream in 5, 4. Thank you so much, and sorry for missing yesterday. 3, and then there's a 2, and the last one is 1. Yep. Bye. Thanks.